So I'm Qusai Shidi. I'm working on simulations of the sun and simulations of the Earth's magnetosphere. So that's the Earth's magnetic field. What I'm trying to figure out is how the energy from the solar wind, which is the plasma that the sun is shooting at us at all times, how the energy of the solar wind transfers itself into Earth's magnetic field. And that's what I'm interested in. That's what I'm studying right now. It's a great question. Very hard to answer during this COVID crisis. But for now, during the COVID crisis, I like to bike a lot. Yeah. Biking is definitely an activity I like. I really like art, I like painting. I'm from a very small country called Oman. Yeah, I moved to the US in 2008 to study physics. So I'm really into simulations of space plasmas. So that's what my thesis was on. My thesis was on the atmosphere of the sun and simulating that. So I'm really into just simulations of the space plasmas, and SOLSTICE is trying to get to a point where we can accurately simulate space plasmas from the sun to the Earth. So that's a big project, It's very ambitious, which I like, and it's interesting for me because it's space plasmas in such a huge scale. So for my PhD, I wrote a simulation for the sun's chromosphere. So what the sun's chromosphere is, it's a layer in the sun's atmosphere that's near the surface, and it's a very tiny layer, and it's much colder than the corona of the sun. So you know how when you draw the sun, you draw it with a crown. That's called the sun's corona, and that's 1,000 times hotter than this chromosphere or even the surface of the sun. So that's an outstanding problem in physics. So I wrote a simulation to simulate this layer, and that's what I did for my PhD. Coming to University of Michigan, I was basically hired for my simulation expertise. So I'm just going. University of Michigan has its own simulations here. So for SOLSTICE, I'm not writing a simulation, but I'm mostly going to be studying simulations, and not only the sun, from the sun all the way to the Earth's magnetic field. In terms of coding, I've been coding since I was very young, I think 12 or 13 years old. I learned C++ when I was living back in Oman, my home country, mainly because, I got a computer in '96, and that I was stuck on that thing because there's not much to do in Oman. So the computer was the most interesting thing to me. So I just learned a lot about computers, and I learned programming at a young age. And I actually wanted to be not a software engineer, more like a computer scientist. But I had a good physics teacher during high school, and that changed my mind. So I got into physics, and I wanted to supplement physics with coding. I never thought I'd be in any astrophysics, astronomy, or space thing. I actually started out more in thin films or semiconductors, but unfortunately, because of funding issues and that sort of thing, I got into the space side of physics, and that was extremely interesting to me. So it still had stuff I was very interested in, which is like electromagnetism and that sort of thing. Like Earth's magnetic field is very important, and in plasmas, electromagnetism is very important. So stuff I'm very interested in, and also I could still use my love for computer science in the sense that I'm writing simulations and I'm coding. Scientists tend to write a lot, but since Solstice just started, I haven't been writing for Solstice in the sense of papers, but that's going to come very soon. So what I do is I check my emails in the morning, and then I start coding a bunch of things, which is coding things for our simulations, and then also running those simulations. I also look at the data from the simulations and try to interpret that data. Science is usually not done by yourself, you know, so there's a lot of discussion between the scientists and the Solstice project here. I definitely have advice, but it's not going to be what you're looking for, because as I've mentioned before, I didn't think I would end up here. So, and that's the thing, you will never have that much control over your life, you know? So having very short-term goals is more important than having a long-term goal of ending up in the position I'm in right now. And setting up expectations like that could frustrate or lead to disappointment. So it's very important to be ready to handle change and for things to not go your way. Yeah, I didn't grow up here. I did high school in Oman, and there was a very rigorous physics program there, which definitely, and as I said, I had a good physics teacher. So sometimes it comes down to that, you know, like having a good teacher. It's not really all up to the student. So I had a really good physics teacher, and that inspired me to pursue being a physicist. And I learned coding at a young age. So I actually went to a computer training institute in Oman to learn a bunch of stuff. So it really helped me learn those skills. But coming into undergrad, I was mainly coding thin film simulations, so like molecules, that sort of thing. And I was also getting into semiconductors, which is specifically photovoltaic stuff, so solar cells and that sort of thing. But when I ended up in space physics, I was just coding a simulation from scratch of the sun's chromosphere, or its lower atmosphere, and I did that for my PhD. So, and that took a long time. Coding a simulation from scratch is not easy, nor does it take a short amount of time. So I spent a lot of time with my PhD. I was doing my PhD for 7 years before I got it. But yeah, I'm recently graduated, so I'm new to the University of Michigan. I graduated last year, so now I'm doing this. I'm hoping, and this is the most ambitious goal, is that we're able to simulate the entire process of the plasma coming out from the sun all the way onto the Earth's magnetic field. And if we're able to do that, that would be very good. Yeah.